Folks, today we are going to be talking about one concept in technical drawing, which is scales. Now, an object is often too large to be drawn for full size on paper. So you can attest to this. If we were to draw everything full size, then our houses um, would be containing large papers, and because of that, the reason why you can see a small drawing of a house on paper, on an A4 paper, is because of this concept known as scales. Now, this scales is a concept that involves making use of a reduction formula. You have scale ratios and not the rest. So making use of that, and an example of this, we'll be drawing a plane scale. So, for example, if we say we draw an object half size, that means every original dimensions will be reduced, will be cut into half. So in this example, let's construct a scale of 2 centimeters equal 1 centimeter to read up to 6 meters in decimeters. So what it means is that you need to understand the concept. We are constructing a scale of 2 centimeters to equal 1 meter to read up to 6 meters in decimeters. So that means we are going to draw a scale in which 2 centimeters is going to represent 1 meter. So that means at the end of the day, if 2 centimeters represents 1 meter, that means to draw 6 meters we would need 12 centimeters. So let's draw a line of 12 centimeters. So starting from the point of 1 to the point of 13. That's a span of 12 centimeters. So I'll draw a line joining them together. Then I'll so this will be, so if 2 centimeters represent 1 meter, so from 1 to 3 will be 1 meter, 3 to 5 will be 2 meter, 5 to 7 will be 3 meter, 5 to 7 3 meter, 7 to 9 4 meter, 9 to 11 5, then 11 to 13 is 6 meters. So now the next thing is to construct perpendiculars above. So we're going to raise this up, we're going to draw heights. So you can see that there's a space between my ruler and my line. So I'll make sure that space is equally is uniform space. So then I'll draw the height. So you don't have to measure the uniformity, just make sure it's uniform by eye level. So because this height they have to be perpendicular. So and the height now. So making use of dimension lines or construction lines rather, construction lines. So now we've raised this up to their original nature. There we go. Now the next step is after raising this up, we can then pick a particular point. Let me just pick an arbitrary point. So that will be the height of this column. So join them together. So I'm joining them together right now. So I'm joining them together right now. Now having done that, the next step is now this 120 millimeter long. That means if 2 centimeters measures 1 meter, that means we have 0 meters, we have 0 meters, we have 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, and 6 meters. So you notice that one of the beauty of scales is that it allows you to do the unbelievable. So in this case, you won't believe that this is up to 1 meter. This is definitely not up to 1 meter. So from 0 to 1, it's actually representing a distance of 1 meter, but it is not actually 1 meter. So anything you see, even what you most of concepts in our today's world, they are actually representations. So this distance is not the actual 1 meter, so but it is a scale that is drawn to represent 1 meter. So you understand that concept. Once you understand this concept of representation, scales becomes very much easier for you to understand and work with. Now the next step is the height of the scale can be any convenience height. So you can see this is a convenience height. Now let's so in this case we've constructed a scale of 2 centimeters equal 1 meter. So this is 2 centimeter in actual length, but its representative length is 1 meter. Then and it's reading up to 6 meters. So this is 6 meters. So this is the span of the scale. Now in decimeters. So what we are going to do is we are going to assume this is actually in decimeters. So we are going to divide each of these portions. That means we are going to have one of these. So we are going to convert. So if this is actually 1 meter, then this is 10 decimeters. So let's calculate the distance of one decimeter. So that can be done by dividing this segment into 10 equal parts. So now all we need to do is you draw a line at an angle and divide that line into 10 equal parts. So I've covered this in the previous video. Let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9. Now let's join the last segment to the original line. So join the last segment to the original line. I'll draw lines parallel to this last line. So I'll draw a line parallel to it. Parallel to it. You'll have the first segment. Let's cut that. Second cut. Third. Fourth. Fifth. Sixth. Seventh. Eighth. Ninth. 10th. So basically, so that means each of these divisions is actually 1 decimeter in length. Now you can make use of this plane scale to measure any length. So but before we do that, let's transfer those divisions to the lower portion. So I'll basically transfer them like this. So transferring them, transferring them. Transferring the distances. Transferring distances. Here we go. Finally, good to go. Now these are the 10 distances. 4, 5, 6, 7, 8, 9, 10. Now, if we were to use this plane scale to measure a dimension, let's say 3.4 meters. So what you are going to do is you are going to start from a span. Let's have this 3. 1, 2, 3. These are 3 whole parts. I will take this perpendicular up. So then I'll take 4 divisions. 1, 2, 3, 4. So I'll raise it up. So that's 3.4 here. So then this will make use of dimension lines. That means this dimension is actually 3.4. So I have 3.4. So this is 3.4 meters. Now you can make use of this scale to measure any dimension to the to 1 decimal place on the scale. But if you want to go further than that, you have to make use of a diagonal scale, and we'll be covering diagonal scales in the next episode.